Right, so starting a new unit today, you're going to hear this word a lot, factoring. We're going to start kind of basic. We're not even looking at anything with variables today. I want to show you guys how to completely factor a number and come up with what's called prime factorization. And basically, if you look at this unit side by side with our last one, the last unit we added polynomials, we subtracted polynomials, we multiplied polynomials, we did all this stuff, putting polynomials together. Factoring is basically taking those bigger polynomials that we came up with and tearing them back apart. So there's going to be a lot of use of this word factoring. Pretty much everything that we do is factor, 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 factor. So today, seriously, we're just looking at numbers. You're not even going to see a single variable in what we do today or tomorrow for that matter. So I want you to focus on like what it means to factor. So factoring is basically breaking something down into its component multiplicative factors. So like what can you multiply together to get 75? So some things that we kind of need to review is some divisibility rules. Like 75, I know 75 is divisible by 5 because the last number is 5. Similarly, over here, I know 140 is divisible by all kinds of things. I know it's divisible by 2. I know it's divisible by 5. I know it's divisible by 10. So kind of keep those in the back of your mind, those like grade school divisibility rules, to help you get started on this. I also don't care if you use a calculator. Have a calculator in your hand while you're doing this too. So I'm going to start by, I know 75 is divisible by 5. So I'm going to make what's called a factor tree. I'm going to split this up. 75 is 5 times 15. Okay, that's the first step. And what I'm going to do is I'm going to take each one of these factors and look at it and see if I can divide it by anything. I want to make this as broken down into its prime factors as possible. All of these numbers that I'm going to break it down into should be prime numbers. If you don't remember what a prime number is, it's anything that is divisible only by itself. So like 2 is prime, 3 is prime, 4 is not prime because you can divide 4 by 2. 5 is prime, 6 can be divided by 2 and 3 and 6. And look that up if you need some more explanation of that. But so I'm going to go back. Okay, so 5, I can't break 5 up in anything smaller than 5 and 1. 15, however, I can divide down into 3 times 5. Okay, so I'm going to do this just to illustrate it. I don't care if you guys do this or not, but what I want you to realize is once we divide a number up, the bigger number is not there anymore. So 75 does not exist anymore. I've rewritten it as 5 times 15. 15 does not exist anymore. I've written it as 3 times 5. So what I'm going to do now is write what's called the prime factorization. I'm going to look down here at the bottom of this list, just at the small prime numbers, and I'm going to write it in prime factorization form. I'm going to put these numbers back together, but I'm going to use, anytime I have a number pop up more than once, I'm going to use an exponent. So I don't have to write out 5 times 5. Now, if you grab your calculator and you multiply those out, 3 times 5 times 5, you will get 75 back out of it. But this is the prime factorization form of 75. You start with the smallest factor and you go up to the biggest one, including the exponents as needed. So let's go back to 140. I'm going to split that guy. That is 14 times 10. Okay, no more 140. 14 is 2 times 7. No more 14. 10 is 2 times 5. No more 10. Now, if you're not real good with your multiplication tables, if you don't know your multiplication facts, you can just grab that calculator and start dividing by something until you get a hit. So I'm going to write this. These are my prime factors down here. So I'm going to write them out in order. That is 2 squared, because there was 2 of them, times 5 times 7. Okay, so your answers that you give me today, I'm simply going to give you a number. I'm going to ask you to do the factor tree and then give me the prime factorization. This is basically your answer down here at the bottom, 2 squared times 5 times 7. Okay, so homework tonight, I'm only giving you a handful of these. Work them out on a sheet of paper, take a picture and turn it in because I want to see these factor trees. All right, 256 and 135. So I'm going to keep this one You know what? I'm just going to say the first thing I see is that this is even, so it's divisible by 2. So I'm going to make that 2 times, that's 128. And that is 2 times 64. And that is 2 times 32. 2 times 16. Keep going and going and going until you can't break this thing down anymore. What's going to happen, the 4, 8, 16, 32, 64, and 128, those are all gone because I split those up. And if you look, what I've got here is 1, 2, 3, 4, 5, 6, 7, 8 twos. The prime factorization for 256 is just 2 to the 8th power. There are no other factors that can't be broken down into a 2 anyway. So this one goes all the way down to just a whole bunch of 2s. All right, 135. First thing I see is that this is divisible by 5. So I don't happen to know that one off the top of my head. 27. Okay, 135 is gone. 27, that's 3 times 9. 9 is 3 times 3. Okay, that's it. Nothing else. Nothing smaller than 5s and 3s. So this is going to become 3 to the 3rd power times 5. Okay, that's your homework tonight, guys. Just a number, break it down to its primes. Your answers will have some exponents in it. It's possible. It's also possible, that if I were to break down something like 30, just to give you an example that doesn't have any exponents in it, right? When these are all split up, my prime factorization is just 2 times 3 times 5. These should be super easy to check and make sure you're getting them right, because all you have to do is multiply this at the end back together and see if you wind up with what you started with. Super easy to check.